All right, good job, everybody. Let's take a look at problem number 11. What we're going to have to do is we're going to have to graph a quadratic, y equals x squared minus 6x plus 5 on this graph. Oh, I love it when they ask us to graph something because we have a machine that's going to create a table for us of points that we plot, and then we're going to just use the graph button to make sure that we have a graph that looks like what it's supposed to look like. So immediately, as soon as I see we have to do a graph, I'm going to go to my y equals button, and I'm going to type in that x squared minus 6x plus 5. We hit, so there we have it. I'm going to hit the graph button, and this is kind of what we want it to look like. But we're not in middle school anymore. We're in high school. We can't just be copying down what we think that graph looks like. We have to get some exact points. So let's go to our table. All right. And let's start plotting some points, writing some points down that we could plot on this. So it looks like the first one, I'm looking at these y values here, they're all off the charts. Looks like the first value that's going to fit here is 0, 5. So 0, 5 is going to be our first point. Then we have 1, 0. Then we have 2, negative 3. Then we have 3, negative 4. 4, negative 3. 5, 0. That's a 0, pardon me. And 6, 5. If we go past that, you can see 7, 12, and that's not going to fit on our graph because there's only 10 up and 10 down. So let's plot these points. 0, 5 would be go to our origin. 0 says don't go anywhere left or right, and the 5 tells us to go 5 up. 1, 2, 3, 4, 5. 1, 0 would be here. Go to the origin, go to the right 1, and then don't go anywhere up or down. 2, negative 3 would give us 1, 2, negative 1, 2, 3. 3, negative 4 would give us 1, 2, 3, negative 1, 2, 3, 4. 5, 0 would give us 1, 2, 3, 4, 5, and then don't go anywhere up or down. And 6, 5 would give us 1, 2, 3, 4, 5, 6, up, 1, 2, 3, 4, 5. Wonderful. I'm breaking my rule here of always doing my graphs in pencil. Oops, I skipped one here. Boom, does that make sense? 1, 2, 3, 4, and down, 1, 2, 3. Yeah, that's right, I skipped 4, negative 3. Pardon me. So I'm breaking my rule of doing it in pen, but what I'm going to do is connect them here all the way around, just like the graph was on the calculator. Now, if I were to stop there, this would be wrong. Okay? This graph continues up and up and up. In fact, if I went just one further, we saw that our value was 12. So even if I wanted to, I could add a little bit extra. It needs to get up here. But I get really sloppy, and I definitely don't want to be drawing my line so it crosses over here or it veers to the left or anything like that. So I'm just going to go a little bit past my arrowhead, my dot, my endpoint there, and put an arrow. And I'm going to go a little bit past this one and put an arrow. Okay? It's always safe to label our graphs too. All right, and we've graphed that one. Let's double check it on our calculator. It looks to be very similar to what we have there. Okay, here's what a lot of people missed when I saw this one on the quiz. After we do the graph, we're a little fatigued. Do not forget this part of the problem. It says state the equation of the axis of symmetry. And we have to remember that the equation of the axis of symmetry is an equation. It's not just a number. So the vertex here is going to be here at 1, 2, 3, negative 1, 2, 3, 4. At 3, negative 4. And the axis of symmetry is 3. A lot of people say 3 because they're remembering that, the axis of symmetry has a lot to do with that first value of the vertex. Except we need to make sure that that's an equation. X equals 3. And that's what gives us our axis of symmetry, which goes right down the middle here, where every single time x is 3. There's our axis of symmetry, right in there. Wonderful. Let's take a look at problem number 12. This says, a school is building a rectangular soccer field that has an area of 5,000 square yards. The soccer field must be 50 yards longer than it is wide. Determine the dimensions algebraically. So first we're going to start by drawing a rectangle. It also says that the area of the rectangle or the rectangular soccer field, is 5,000 square yards. So I'm going to write 5,000 in there, implying that that's the area of this whole space inside the rectangle. It tells us the soccer field must be 50 yards longer than it is wide. So it's talking about width and length. It says that it's 50 yards longer than it is wide, so that would make our length equal to W plus 50. That's 50 yards longer. Then what I like to do is circle the common variables so that we don't get screwed up on which ones to use. All right, that's a good first step. Then we're going to remember that area is the same thing as length times width. All right, so now let's do some replacing. Area, well, that's the same thing as 5,000 square yards. That's what it told us in the problem. Length, we're not going to use L anymore. We're going to use W plus 50. So that length is going to become W plus 50. And our width, that is the one that we're using, so it's going to end with a W. All right. Don't forget, even though the W is on the other end, the right end of it, we still have to kind of reverse distribute this thing here. Boom, boom. And we'll get 5,000 equals W squared plus 50W. Getting close. Now we just need to solve this thing. So we're going to go from that 5,000 equals W squared plus 50W. Remember, if we're solving quadratics, we have to make them equal to 0. So I'm going to take this 5,000 and we're going to move it over here. So when the 5,000 gets moved, it's going to turn into a 0 equals W squared plus 50W minus 5,000. My bad, I wrote that so sloppy that I'm going to have to write it again. 0 equals W squared plus 50W minus 5,000. Now how are we going to solve that? Well, we're going to have to factor it first. So we know that we're going to have a situation like this. We know that W is going to go in the front. We know that our sign situation, since this is a minus, is going to be plus and minus. And now, instead of making a gigantic factor chart of that number 5,000, let's just try to think of two numbers that are going to multiply to be negative 5,000 and add up to be 50. I'm thinking in my head that 5 times 10 is 50. So 5 times 100 would be 500. What about 50 times 100? 50 times 100 is going to give me 5,000, and that way if we have a 100 here and a 50 here, yeah, that's going to multiply. W times W is W squared. W times negative 50 is going to give us minus 50W plus 100 more W here. That's going to give us positive 50W. And 100 times negative 50 is negative 5,000. Wonderful. Now we just need to set up our two situations here. We have W plus 100 equals 0, or we have W minus 50 equals 0. In this situation, what minus 100 is equal to 0, well, W is going to have to be negative 100. And what minus 50 is 0, well, W here will be equal to 50. Now, I'm going to reject this negative 100 because width can't be negative. So what's our width? 50. But be careful. This problem asks us for the dimensions of this rectangle, which means we need the width and the length. So if the width is equal to 50, and we know that the length is equal to the width plus 50, we know that that's going to be equal to 50 plus 50, which is 100. So if we were going to say what the final answer is here for the dimensions, make sure we include units too. The width is going to be 50 yards by 100 yards. There's our final answer there. Great! Last problem, we're almost there. It says, let f of x equal negative 1/2 x squared and g of x equal x minus 4. On the set of x's below, draw the graph of y equals f of x and y equals g of x. Hooray! A graphing problem. All we have to do is plot some points and connect the dots. Let's do f of x first. That says negative 1/2 x squared. So I'm going to put my negative sign there. Oh, fractions. Remember, it's alpha. Y equals. Enter. The top number is going to be a 1. The bottom number is going to be a 2. To get out of that fraction, I hit the right arrow. And we got an x squared right there. All right, let's take a look at what should this look like if we do graph it. Okay, it's going to be upside down parabola. I see because it's negative, and it's going to be a little wider than usual because that's 1/2. Okay, let's look at the table to get some exact values. I'm going to go up here to all the negative ones I can use. Looks like the first one, -4, -8 is the first one that's going to fit on there. I'm going to go to -4, 1, 2, 3, 4, -1, 2, 3, 4, 5, 6, 7, 8. There's my first point. I can't put -3, -9 halves because it's a pain to have to put a half value on a grid that's not scaled out that way. So the next one I'm going to plot is -2, -2, -2, -2. Then let's keep going. Looks like 0 zeros on that graph. Okay. 1, -1 half isn't going to be convenient. Let's do 2, -2. 1, 2, -1, 2. Oh, I'm noticing that must be our axis of symmetry. It's the same distance away. Let's just get this next one and see if we're right. If we go on this line here, it's 1, 2, 3, 4. This point's 4 away from the y-axis. Let's go here, 1, 2, 3, 4 away from the y-axis, which because it can use the y-axis because that's our axis of symmetry. Let's see if 1, 2, 3, 4, -1, 2, 3, 4, 5, 6, 7, 8. 4, -8 showed up. Yeah, there it is right there. So as we continue to connect the points, it's going to look something like this, then like this. Okay, and then we want to make sure we label that f of x. We don't want to get it confused with anything else. Anytime you put more than one graph on a grid, label them both. Let's move on to g of x, x minus 4. I'm going to clear this one out. Just do x minus 4. Go to our graph, and we can see, oh, it's going to be a line shooting up like this. Cool. Let's get some points from that graph. Looks like -1, -5 would be a convenient point. -1, -1, 2, 3, 4, 5. 0, -4, 1, -3. Oh, I can see a pattern starting to develop that goes up 1 to the right 1 all the way through. So I get those. Pardon me, I need a protractor. Luckily I have one right here. Go connect these points right here. It looks like I'm getting 2 points of intersection with this line. I'm going to put arrowheads because I didn't take up all the space on the graph, and we're going to label that g of x. Wonderful. Okay, so here we got our f of x and g of x. They're graphed. Now, that's not all, because the last part of this problem says, using this graph, determine and state all values of x for which f of x equals g of x. So where do f of x and g of x, where are they equal to each other? Let's use a different color here. Where are they equal to each other? Right here where they intersect, and right here where they intersect. So what are those 2 points of intersection? Well, the first one's right here. It looks like it's at -1, 2, 3, 4, -1, 2, 3, 4, 5, 6, 7, 8. So -4, -8. And what about this point of intersection? Looks like it's at +1, 2, -1, 2. +2, -2. Now, be careful. These are the points of intersection. But the question is asking us to state all values of x for which f of x equals g of x. So the answer would be just the x values, -4 and +2. Hey, nice work, everybody. You completed the entire 13-problem practice test. Hope that helps, and best of luck.